All right, hey, we're on, slideshow 16, page 44, doing some more conditional derivation examples. These are examples 3 and 4, and you get to see my giant hand again. All right, so number 3 has just one premise: if P and Q, then if R, then S. So let's write that down. If P and Q, then if R and S. And we're trying to show if R, let me just write it down here, it'll be easier than trying to say it. If R, then if P then Q, then if P then S. So really long kind of conclusion with lots and lots of conditionals, which should suggest to you that you're going to be doing conditional derivation. So let's write down our notation here. We've got, make sure you can see that, PR for premise, and then we're going to do a conditional derivation here, but we won't write it down until we've completed it. Okay, so the name of the game here is just to make sure you keep track of your main connectives. In this case, our main connective is right here, the arrow. And so conditional derivation tells us we can assume the antecedent, that is R in this case. And after making that assumption, try to show the consequent, which in this case is everything after that first arrow. So we're going to try to show this. That is, if P then Q, then if P then S. But of course, notice we've got another show line with the main connective being a conditional. And so we're going to do conditional derivation again, and that's the main connective this time. So we get to assume everything before that, everything in the antecedent, so we get to assume P arrow Q. And we're going to try to show P arrow S. But look, we've got a show line now with a conditional. So once again, we get to do conditional derivation. This time it's pretty straightforward. We assume P and try to show S. Now we sort of bottomed out. We're just going to have to actually do some proving here. We can't just set up more and more show lines. We need to do some derivation. But again, let's look and just see what lines we have available right now. Let's just remind ourselves. We've got line 7, line 5, line 3, and line 1. Line 1's our premise, and 3, 5, and 7 are all assumptions that we are entitled to make in our conditional derivation. So the goal now is to use 1, 3, 5, and 7 to somehow get S. So the first thing I'm going to do is notice that we've got P and Q in the antecedent of the conditional in line 1. So I'm going to try to get P and Q. How can I do that? Well, I've already got P. And if I put P and P arrow Q together, I can get Q, and that's going to be my way to get P and Q. So with 5 and 7, I can get Q. That's 5 and 7 by arrow out. Now on 7 and 9, I've got P and I've got Q, so I'm going to get P and Q. That's 7, 9 by and in. Good. So now on line 10, we've got P and Q, and up here we've got if P and Q, then something else. That is R and S. So arrow out tells us we can get R and S from 1 and 10 by arrow out. So far, so good. We're looking for S, and hey, look, we actually see that we've basically got it here. All we have to do is take it out of the conditional. That is from line 11 by and out, which tells us you can take either half of a conjunction, an and sign, an and formula. You can get either part. So we'll take S out, which is what we're trying to show, and so our proof is now essentially done. We're trying to show S. We've got it at the bottom of our proof. So that means it's a direct derivation. That is, we directly derived S, so cancel and box. We showed S after assuming P, which means we conditionally derived P arrow S. We showed P arrow S after assuming if P then Q, which means we showed if P then Q, then if P then S. That's again a conditional derivation. And finally, we showed all of that after assuming R, which means we showed if R, then all of that's true. So again, another conditional derivation. and that's the end of the proof. So it's really, on this one, a lot about the setup of the proof, setting up those show lines and the conditional derivations. The actual derivation itself actually follows pretty quickly. All right, last example I'm going to do on this video is a short one, but I just wanted to illustrate something sort of interesting about conditional derivation. Make sure you can see this here. So we've got two premises, P or Q, and not Q, and we want to show if R, then Q. So we write down that these are our premises here, and we leave this open until we've completed the proof. Now if we're going to show R arrow Q, what should we do? Well, it's a conditional. The main connective is an if-then. So we're going to do conditional derivation just as we're now used to. We're going to assume R and try to show Q. And let's see how this proceeds. Sorry, did I write down the wrong? I wrote down the wrong premise. We're not going to be able to show Q if not Q is one of our premises. This should actually be, excuse me here, this should be not P here is our premise. All right, so we got P or Q, not P, and then we're going to show this. Okay, so look at 1 and 2 here. P or Q and not P. Well, by or out, we can immediately get Q from 1 and 2. And look, that's what we were trying to show, Q. So we directly derived Q, which means we conditionally derived if R then Q, because after assuming R, we were able to show Q. So that's conditional derivation. So it's a very simple proof in this case, but I just wanted to say something interesting about it, just draw your attention to something. You might think there's something odd about this because after all, even though we assumed R here, we never made use of it in deriving Q. That is, we derived Q from 1 and 2 alone, neither of which used that assumption. But that's okay. Conditional derivation says that if you're able to show Q after assuming, well in this case it says if you're able to show Q after assuming R, then you've shown if R then Q. It does not say that you have to use that assumption in your derivation of Q. It just says if you can merely show Q after assuming R, whether you use R or not, that's sufficient to show that if R is true, then Q is true. All right, that wraps up these two examples here. On the next video, we'll look at some harder conditional derivation examples, but these ones should at least get you started with the basic concept.